In this example, we're going to calculate the residuals and estimate sigma squared given the least squares regression line of y hat equal to 1.5 plus 1.5x. So here is our small data set. And what we want to do is we want to find the residuals. And if we recall, the residuals are y minus y hat. Basically, this is the difference between our observed y value and the predicted y value for the same value of x. So the first thing we need to do is we need to calculate our predicted values. So y hat is equal to 1.5 plus 1.5 times our x value. So for the first observation, we're going to plug in 1, and we get y hat to be equal to 1.5 plus 1.5, which is equal to 3. So for when x is equal to 1, it's right here, when x is equal to 1, our y hat, or our predicted value, is equal to 3. So for the next observation, we do y hat 1.5 plus 1.5 times 2. So when x is equal to 2, what is the predicted value of y? It is equal to 1.5 times 2, which is 3, plus 1.5. So y hat is equal to 4.5 when x is equal to 2. All right, so we can see that for this next observation, the y hat is the same because the x value is equal to 2. And for the last observation, x is equal to 3. So to find the predicted value, we do y hat is equal to 1.5 plus 1.5 times 3, which is 1.5 plus 4.5, which is equal to 6. So the predicted value is equal to 6. So if we want to calculate the residual for each one of these values, because there is a residual for every single point in our data, if we want to calculate the residuals, that's y minus y hat. This is the residual. We can simply just subtract 3 from our predicted value, so 3 minus 3 hat, or 3 y hat, is equal to 0. Then 4 minus 4.5 is equal to a negative 0.5. 5 minus 4.5 is equal to a positive 0.5, and 6 minus 6 is equal to 0. So our residuals are 0, negative 0.5, 0.5, and 0. So we've calculated all the residuals for our least squares regression line and for this small data set. Now we need to calculate the estimate for sigma squared. This is the MSE, or in other words, S squared, and this can be calculated by summing the residuals y minus y hat squared all over n minus k plus 1. So this is equal to the sum of each of the residuals squared divided by n minus k plus 1. These are just equivalent statements. So we can easily get s squared by taking the residuals that we've already calculated this. So let's get rid of some of this stuff. So we've already calculated the residuals. This will be equal to the sum of each one of these things squared. So we do 0 squared plus negative 0.5 squared plus 0.5 squared plus 0 squared again, and divide it by n minus k plus 1, where k is the number of explanatory variables in our model. So we only have one x, which means that k is equal to 1. So our denominator is going to be n minus 2, where n is equal to 4. So 4 minus 2 is equal to 2. So we get this to be equal to negative 0.5 squared, which is, well, 0 squared is 0, plus negative 0.5 squared is 0.25. 0.5 squared is also 0.25, and 0 squared is just 0 over 2. So this is 0.5 over 2, which is equal to 0.25. This is then our estimate for sigma squared, the true variation in our population. or in a sample case, it's called the mean squared error, or S squared. This is our estimate for it. All right, and so now that we've calculated the mean squared error and all the residuals for a small data set, we could have also done this using software, and most likely will if we have a larger data set.